Welcome back. The greatest common divisor. Let a and b be integers, not both 0. The largest integer d such that d divides a and d divides b is called the greatest common divisor of a and b. The greatest common divisor of a and b is denoted by GCD parenthesis AB. The two integers a and b are called relatively prime if GCD is 1. That is, the only divisor, positive divisor a and b have is 1. Common divisor is 1. Find GCD of 24 and 36. Find GCD of 124 and 236. So let's go through by guessing. 24 and 36. Well, 1 divides. Does anything bigger divide? Yes, 2 divides both of them. Does anything bigger than 2? 3. Yes, 3 divides both of them. Anything bigger than 3? 4 divides. Yes. Bigger than 4. Does 5 divide? No. 6 divides. Yes. After 6, 7, 8, 9, 10, 11, 12. Yes, 12 divides. After 12, keep counting. You will find nothing else beyond 12 divides both of them. So 12 is the GCD. What about GCD of 124 and 236? Does 2 divide? Yes. Well, I should always start with 1. Does 1 divide? Yes. Anything bigger than 1? 2? Yes. What about bigger than 2? Does 3 divide? 3 doesn't divide this number, so it won't divide this. It won't be a common divisor. Does 4 divide? Yes. Anything higher? Well, we can keep going and checking. Okay. So this seems to be a harder problem than the one we just encountered. We have to keep going a few times to figure out whether we have a GCD, that is greatest common divisor, bigger than 4. Let's see. There is a beautiful Euclidean algorithm. This is an efficient algorithm to find the GCD. This algorithm has been known since ancient times. It's named after the ancient Greek mathematician Euclid, who included a description of this algorithm in his book, The Elements. First, let's go through a lemma. Let A equals BQ plus R. A, B, Q, R be integers. A is dividend, B is the divisor, Q is the quotient, R is the remainder. Then GCD of AB is equal to GCD of BR. Notice AB and BR have the same common divisors. Why? If anybody divides A and B, then they of course divide R, because A minus BQ is R. Any factor of A and B will be a factor of R, B and R. Yeah, any factor of A and B will be a factor of B for sure, because it's a factor of B. And because R is difference of the two, it's a factor of R as well. Okay. On the other hand, any factor of B and R is a factor of B by being a factor of B, and sum of them is A, so is a factor of A. So any factor of the pair AB is also a factor of the pair BR. So the largest factor here is also a factor here. The largest factor of these two is also a factor here. So you need, therefore, the factors of the greatest factors are equal. All right. So here is the Euclidean algorithm. Start with your positive integers AB. Call x to be A and y to be B. Look for the remainder. As long as y is non-zero, look for the remainder when x is divided by y. Okay. So now instead of checking for A and B common divisor, you are now looking for B and R common divisor. So your divisor became the new dividend, and your new divisor is the radius, basically radius. Here we go. Okay, so instead of finding common factor of A and B, you are now finding common factor of B and R. Why would you do that? You would do that because R gets smaller and smaller. Eventually this you will, when you y is 0, when the divisor is 0, dividend is your GCD. That's the Euclidean algorithm. So now let's use Euclidean algorithm to find GCD of 24 and 36, 124 and 236. If you remember, this we eyeballed it and found a greatest common divisor. This one we left hanging. Okay, so 24 and 36 we checked through divisors and came up with the correct answer. 124 and 236 we said, well, we'll have to keep checking for a long time. Let's look for another method. So here is the Euclidean algorithm. X is 24, y is 36. Is y 0? No, y is not 0. So the procedure says find the remainder when x is divided by y. 24 is divided by 36. Well, 36 is bigger than 24, so quotient is 0, remainder is 24. So now x gets the old y, so the divisor becomes x, and the new divisor is the remainder. Okay, the point is to make the first number bigger than the second. All right, so y has become smaller, it's not yet 0. Divide x by y and find the remainder. Well, remainder is 12. That is your new y. So your y is always getting smaller. So y is small, x becomes the previous y. Now that's y, that's x. Divide 24 by 12 and look for remainder. Remainder is 0, that is your y, and x becomes your previous y. Okay, so instead of 24, 12, now you're looking at 12, 0. Well, y is 0. Moment y is 0, x is your greatest common divisor, and that's your GCD. Do the same procedure for a larger pair. 124, 236. Y is not 0. Divide x by y and let y be the remainder. So from 236, y became 124. X is the previous y. Divide 236 by 124. Find the remainder, that is your new y, and x is your previous y. So look, y has gone down. From 236, it went down to 124, went down to 112. Divide 124 by 112, find the remainder, that's 12. That's your new y. X is your old y. Divide 112 by 12, look for the remainder, remainder is 4. That is your new y, and x is your old y. Divide 12 by 4, find the remainder, that is your new y. X is your old y. Aha, now y is 0, so you have to return the current x value, that is your GCD. Alright, so that's the Euclidean procedure. Go through this procedure for a few other examples, you will get it better. Alright, so this completes lecture 14. We'll continue lesson 15 in our next video. Until then, bye.